Good afternoon, everyone. So we'll be starting in 2 minutes. Thank you. Good afternoon, everyone. A very warm welcome to our webinar on silage technology and its importance for quality milk production. My name is Bhavna Reddy and I am Digital Marketing Manager of Nutrico India. At the outset, I would like to thank you all on behalf of entire Nutrico team for joining us today. From the team present with me are Dr. Suyash Vardhan, Regional Technical Manager, Ruminants, Trau Nutrition South Asia, and Mr. Alad Aisling, Global Technical Manager, Dairy, as the speakers of the day. So before we begin, just a few guidelines to ensure that there are no interruptions in your experience today. Firstly, keep your audio on computer audio mode. And also we are live on Facebook and YouTube now. So if anyone is facing any difficulty here, so you can join us on our Facebook and YouTube as well. So I'll be leaving links in the chat box so you can access it from there. And finally, question and answer round, we'll be taking it in the end after our speakers will present. So we'll be taking up all the question and answers in the end. And the people who are joining on Facebook or YouTube, so if you have any queries, you can type in your questions in the comment section. So we'll be taking up all the questions in the end. So now let us start with our webinar, and I'll be introducing our first speaker of the day. So we have with us Dr. Suyash Vardhan, Regional Technical Manager, Ruminants. He holds a master degree from US Bangalore. He has more than 19 years of experience and specializes in dairy farm nutrition and livestock feed and management. He has previously worked in varying roles from product management, technical and marketing roles, and various other roles before joining Town Nutrition in 2016. So over to you, Dr. Suyash.
Thanks a lot, Bhavna. And I really thank everyone, those who have joined us here. So we would like to just take you through for basically when we are talking about silage. So let's begin with this. And Bhavna, I will be requiring your help because I won't be able to see things through. So in case everyone is able to see my screen, just let me know, Bhavna.
Yes, it's visible, Suyash.
Fair. Thank you. Thanks, everyone. So let's start with what I would like to talk about. Just a moment, please. So silage, when we are talking about, so as you know, that milk starts with forage. In ancient time, when dairy animals were living in the wild, it was only forage which they were thriving on, and that this is how the milk was produced for the neonates, just to thrive. So it is very important when we are talking about milk, so it is what is being fed to the animal, it's reflecting in the milk. So that is the reason that whatever we are feeding, as forage is also an important part to produce good quality milk. So I would like to take you through what experiences which we had silage preservation and management in tropical climate. So when milk we are talking about as now dairy is in the commercial setup, and people are doing dairying not just as a hobby, but it is becoming a commercial venture. So when we are talking about milk is being produced from dairy animals, it's very important to understand that how it impacts animal, and anything which we feed, whether it is a compound feed or it is silage or any forage, how it impacts cow's body and how it is its traceability is in terms of milk. So when we are saying specifically today, I will be talking about South Asia because this is where we are addressing gathering today. It is important to understand that there are multiple challenges, be it genetics or be it management at dairy farm. So as in South Asia, we are into a largely fragmented dairy setup. It's very important to understand that how even silage can turn the things into a profitable setup. So it is very important, and if it is a commercial setup, how economic production we can uh, take from our dairy animals. So when we are talking about dairy feed, so compound livestock feed is one of the important thing which is being fed, and forage, as we know that there is a lot of population pressure in South Asia, so forage lands are scarce. And as per recent studies which has been carried out some important government institutes in India, that by 2025 there could have been anywhere 35 to 40% of forage deficit. So considering that, silage preservation is the only way out if we would like to consider that dairy should thrive in this particular South Asian region. So when we are talking about which are the important animal factors which impact quality of the milk, one of the most important thing is animal. So when we are talking about dairy animal, I am taking both consideration of dairy cow as well as buffaloes. So animal genetics and the way we manage it at dairy farm, it is very important to look into. So as I said about land pressure, the same thing we have observed in most of the dairy farms, that animals comfort is actually a challenge because of scarcity of land. So it is very important that we really look into whatever is being fed to them. Today, I would like to be there are a lot many things which we can talk about, but in this particular discussion, I would like to confine myself to largely on feed and fodder. So when we are talking about specifically fodder, which comprises roughly around 60 to 65% of the dairy animal diet, it's very important that we need to really look into the specificity of fodder. And as I mentioned this already, that green fodder availability is limited. So we will be talking today about most important thing, which is silage. So when we are talking about silage, its importance already I have mentioned that once it is processed, even you can keep it around the year. So the nutritional profile, chemical profiles, and microbiological profile, if it is taken into consideration, it become easier that we can ensure sustained nutrients all through year to our dairy animals. So when we are talking about physical and chemical parameters, it's very important that we see that what kind of things we are looking into. And here I would like to specifically mention chemical parameters, because the most important thing is that if we would like to understand the characteristic of good quality silage, it is very important that how it looks like. So pH is one of the important factor. Color consistency are physical parameters which are much known to the industry, but at the same time chemical parameters, when we started this particular things in India, we have seen that largely challenge were specifications on good quality silage. So there are different, I do not want to go into detail nitty gritty, but it's very important to look into if we are saying that good or bad quality silage, its nutritional profile and microbial profile narrates that. Now, I would like to take you through what are the main challenges in forages which we are getting. When we are talking about silage, I have spoken to a lot many stakeholders. People start looking into silage once it has reaches to their processing plant, or farmers take their crop to their bunkers. But let me tell you that for good quality silage, actually it starts with the land itself. As you know that mold and bacteria, their spores, they thrive in soil. So always it becomes a challenge if you are not taking into this thing into account. It will always challenge the plant. And plant, once its immunity, especially during summer season or droughts, when immunity is challenged, then mold and bacteria, they take over plant. And once plant is challenged, then automatically the quality of silage deteriorates. Here I would like to say that whenever anyone is thinking about silage, so first start thinking about the crop. So it's very important to connect with the agronomist, look into its genetics, the seeds which you are sowing, whether it is suitable to the agroclimatic condition, it's what is the fertility of soil, looking into intercropping distance, pest management, look at the way crop is being cultivated, having the right harvest decision, transportation, because these are the all steps where corn can get contaminated. And if contaminated corn is not preserved better, then instead of good quality silage, you can also get detrimental impact on your animal with bad quality silage. So I'm talking about just to mention those who are not aware, as I know that now silage technology people have started understanding. The important thing is those who are not aware, it is for them. For harvest decision, it is very important to look into the dry matter because it decides, and then only you can place your preservation technology that how you need to go for. So half of the milk line, those who are not having lab setup at their basically for farmers it's difficult, but for silage balers, those who are not having lab setup, it's very important that they can look into the half milk line from where they can start harvesting crop and start ensiling. Most important thing is chop length, why I keep on recommending it. Very finely chopped corn silage, its passage rate will be higher in rumen of the animal, and basically it does not serve purpose. And a lot of starch will get fermented at lower gut instead of rumen. So it's very important that one needs to process kernels. So this is globally accepted norm that at least corn seed should be cracked 90%, unless there will be always challenge. And pan state separator, particle scorer also people call it. So this needs to be taken into consideration unless it becomes a challenge for anyone who is giving very fine chopped corn silage to their dairy animals. So this is for corn silage. This is an indication. Today we will be largely talking about corn silage because in one talk it's very difficult to talk about all, but it's very important because 90% of silage processors in South Asia go for corn silage. So it's very important to look for these considerations. So upper, middle, and lower sieve, this gives you indication that how fermentation of good quality silage will happen in rumen. This is very important to understand that what is the silage fermentation process, because if one is having this consideration, it becomes easier to decide about the preservation. So most important thing is I do not want to go in too technical, but briefly I would like to mention that once plant is cut, harvested, and comes for baling or ensiling in bunker, then is still plant cell it respires. It gets interacted with the sugar which is available in the in the silage, and then there is CO2 anaerobic condition starts happening, and there will be generation of heat and water. This is the time, if it is not being taken care of, Clostridium spores take over. And if Clostridial concentration is higher, then it is going to alter the fermentation into butyric acid fermentation instead of acetic acid. And this is how silage gets spoiled. So it is very important that we always say to any of the farmer, because when we around 20 years back, when I started interacting with farmers regarding silage, people were chopping too close to the land. And when you chop or harvest corn crop very close to field, a lot of soil contamination happens. And as already I told, that Clostridium is one of the menace which alters this fermentation. So you need to really 6 inches above you need to harvest so that there should not be soil contamination. The acetic acid, if once it takes over on second day, it creates the template for lactic acid, whether it is naturally acting lactobacilli or artificially induced or externally induced inoculants. Ultimately, it depends upon, most important, that you need to create the right environment for acetic acid to come in picture. And then subsequently, it's lactic acid acetic acid ratio which needs to be taken into consideration. And storage space or storage phase starts after 21 days. So lot many persons they ask that at 7 days can I open my bunker, or on 21 days or 22nd day can I open my bunker? Answer is no, because this is the naturally occurring process. Even if any preservative you are inculcating in this, it does not mean that your silage will be ready faster. This is the natural occurring process. That is the reason post laboratory experiences and in vitro modeling, with confidence we can say that it is very important that we need to look into consideration that at least aerobic stability should arrive, which only happens basically after a storage phase. So this is what goes wrong if we are not following, if we are opening silage bale or bunker early, then aerobic deterioration starts, and the moment re-exposure of oxygen happens, then molds take over and silage starts getting spoiled. So this is something we don't have standard recommendation, but our recommendation is at least even if you are in haste, then before storage phase arrive, 21 days, please just take into consideration that there will be aerobic stability, good aerobic stability can be arrived only after that. Many of the dairy advisors, they said that there are certain technologies which can allow to be reach at pH 4. Undoubtedly, there are solutions which can enhance pH to raise at 4, to keep it down at 4. But again, the challenge is that the moment early you open, it alters the system. So this is what I keep on telling about molds and clostridium. These are most challenge. So anyone who is putting silage in soil, that is the reason I recommend that if it's there is a small farmer, especially for South Asia, I always say that silage baling is important instead of putting in bunkers only. Because if you don't have infrastructure, depend on the suppliers, those who have right infrastructure. So that is the reason that we always technically and strongly recommend that if a farmer is not having right infrastructure to preserve silage, he should depend on basically the commercially available setups. This is also an important thing that if the single row harvesters pose this challenge, and normally we have seen that because of this particular impact, if chop length is bigger, and there are rings of corn which are coming in silage, if it is not cracked properly, or it is not basically cob is not processed, kernel is not processed properly, this is a sheer loss to the farmer. How it in terms, we try to calculate it in terms of whatever is coming in the manure. If suppose this kind of rings comes in silage, then there is approximately one third to one half, 50% could have been basically starch, which is lost in manure. It means the valuable ingredient is lost in manure, and it is going to impact your milk production as well as quality. Temperature is also important thing. If there is any hot fermentation which happens, always remember that when we are ensiling, so after ensiling, the pit temperature goes higher by 8 to 12 degrees Celsius. So it's very important to see that in tropical climate, where temperature is already 40 degree plus, as I know that many of the persons, they are aware about this particular thing, that in this season in itself, is starting of summer season, we are facing at many places temperature is going above 40 degree, and harvest will happen somewhere in the late May or June. By that time temperature will be really high. So it's very important that if you are ensiling, you need to take temperature into consideration. Silage baling, it's I always recommend that professionally silage balers, you really take care of it, because if it is haphazard and soil contaminated, ultimately it is going to hit animal. This is what technology with we have done with thermal imaging cameras. So wherever you are able to see red zones, this is hot fermentation, and we call it as dead silage. And there is mold growth, which is very common in such pits. Nutritional recommendation when we are talking about maize undoubtedly comes out of every other silage. Looking into nutrients which are available, it is most suited, but it does not mean that you cannot go for other quality silages or other variety of crops. It can be, but again, the thing is that don't expect the similar results what corn can give. So we have done comparison maize as well as we have done with grass silages. Overall NDF content is higher in that. And again, when we are looking into basically the nutrient profiling, then preservation quality also depends upon the raw material which we are having. Again, the similar thing which we have done for wheat silage, sugar grains, as well as oat silages. Again, it is not matchable to corn, but where corn is not available, we have developed a system at Trow Nutrition that the preservation technique modulation we advise, looking at the overall nutrient profile of the crop. Now, bad quality silage, it impact milk because where there is mold infestation, and as I mentioned about the clostridial infiltration to the silage material, we have seen lot many challenges like mastitis. It's very common in these animals. We have seen pulmonary affections. We have seen digestive disorders, and in terminal cases, if it is rarely known, it may result into early abortions also, and it is well documented, and in last 5 years we have seen that it is interlinked, and once animal goes under disease condition because of bad quality silage, automatically you start seeing lot many milk challenges, especially in terms of increment in somatic cell count. What are the important tests which we can look into milk quality? There are general tests, but again, I am saying that whether it is mycotoxin contamination or bacterial contamination, we have seen consistently at most of the village level milk collection centers that some of the tests which we have carried out, we have a strong belief that if feed, especially silage quality, is not better, then you keep on getting a lot of challenges. Especially we have seen that those who are still adhered to old conventional method of incorporating molasses, salt, urea, copper sulfate in silage, there we have seen that silage quality gets deteriorated easily. For that particular thing, 5 years back, we have set up this laboratory in Hyderabad. Now, another laboratory we are coming up in the state of Gujarat in India, and we have seen consistently we are extending these services to our customers. I won't talk about much on laboratory because my colleague Mr. Allard Essling will be talking about it. But these are the already Nutricos technologies which are available for silage, determining silage quality, and in terms its impact which can happen on animals. Some of the solutions which we have, it is specifically, these are the complete basket which we have for silage. Filex flow is specifically for the balers, those who are making silage bales. It is basically organic acid combination along with very high quality surfactants. So it can gel up if as a nutritive media you are using inoculants, it can gel up with that. And even without that, if you would like to control your cost, this also helps in preservation. The whole idea is because surfactants does effective water management, and organic acids in beginning itself it arrests clostridium, and simultaneously ready organic acids gives impetus to naturally occurring lactobacilli, or even if you are inoculating something, it creates favorable environment so that it can flourish within the silage. So it's very important. Normally, I have seen that most of the silage balers, they say that it's very tough market. There is a lot of competition, but always my recommendation is you input a lot of capital into it. And if you are even losing 5% of the silage which you are ensiling, suppose you are ensiling over 10,000 tons, even if you are losing 5% or 10% of it, it's worth looking into the right preservation solution instead of looking at that what will be the cost of preservation. Because if silage in itself is not rightly preserved, it's very difficult that around the year you can convince your customers that you are ensuring good quality silage to them. Filex forte, it is with ActiProp technology. So it is for basically farmers, those who are making in bunkers. This is actually basically this solution has been designed where soil contamination happens, and there are also mechanical compression cannot be arrived. Either it is dry matter is increasing or there are other related challenges at farm level. So this is specifically for the farmers, those who are going for bunkers, and even if there is some mold contamination because of all means best of efforts even you are doing it, but contamination happens, then in TMR even you can control molds and Clostridium through Celco TMR. And for healthy quality of milk, we always recommend that this is not treatment, but this is prevention. Go for very high quality toxin binder so that at least you can ensure that mycotoxins, which is having human health hazard, as well as much impact on animals' productive and reproductive potential, needs to be adopted for it. With this, I would like to again thank everyone, and any question is related with it, we will be discussing at the end of this talk. Thank you, Bhavna. Over to you.
Thank you, Dr. Suyash. So, okay. So, thank you, Dr. Suyash. Thank you for the valuable insights. And for all who are listening to the webinar, please type in your questions in our question box. And those who are live on Facebook and YouTube, you can post your questions in the comment section. So we'll be taking up questions from there. So for the next, the next speaker of the day is Mr. Alad Aisling, Global Technical Manager, Dairy. He's a graduate in agriculture and animal production and completed Masters of Business Administration from TSM Business School, Netherlands. With more than 17 years of experience, Mr. Alad works with the global dairy and Nutriop team. And he plays a critical role in developing new technologies in dairy and deployment to customer lab. He's a nutritionist and has worked in formulation and process management. Welcoming Mr. Alad. Over to you, Mr. Alad.
Thank you, Bhavna. Thank you all for being here and being able to listen to this webinar. I'll try to share my screen at the moment. Can you see my screen, Bhavna?
Not now. Actually, I was able to see earlier.
Okay, maybe then you push slides. Can you push the next slide, please?
Okay. Sure. Just give me 1 minute. I'm just showing my screen. Okay, so are you able to see my screen?
Yeah. Okay, so next slide, please.
Alad, can you see my screen?
Yes, I can see your screen. Yes, thanks.
Okay, yeah, thanks.
Can you push the next slide? I can do. Okay, so sorry for the disturbance at the beginning. What I would like to talk to you today about is silage quality and how we can measure and analyze this. But I would like to take one step back and look at the developments we saw globally. When you look at the picture at the right side, we see in the US it was in 1944, cows produced 548 pounds of milk. It would be about 2,000 kilo milk per cow per year. And today the average there will be about 10,000 liter. In Holland, where I am at this moment, it's 9,200 kilo per cow per year. We see this change did not come overnight, so it took quite some years before we got to this milk production. And I do the calculation, the amount of growth, the kilo milk per year growth is about 100 kilo milk per cow per year, but the production increased both in the US as in a lot of Western European countries. So we are able, and that's the interesting part, to do with less cows to produce more milk, and that's more efficient. So the largest contributors to this milk increase is know-how. We know better how to handle animals, how to do this. Genetics, also what Suyash already said, and the genetics of the animals, the feed, and especially the roughage quality. We made great steps in the better digestibility and better availability of roughage. And of course, the animal health and welfare. Next slide, please, Bhavna. So what we want to do is we want to enable the animal's full potential. We need good, healthy, good performing animals. And therefore I require, or the animal requires, good nutrition tailored to their need. It will also affect your business results. And by doing this, by getting towards this, we need to know the composition quality of the feedstuff, link it to the animal's need and the market conditions, because you can imagine if the milk is very expensive and the feed is very cheap, you want to produce as much milk as possible. If the feed is very expensive and the milk is not too expensive, you need to balance in the right way. You can make other decisions. And we also need to implement, we call it precision feeding. And that's based, okay, what's real the requirement of the animal? How can I get to the best possible time, the best quality of feed in this animal? Meaning your diet for your high producing cows should be different, at least, than your low producing cows. Next slide, please. So then I question, why do we analyze feed? First, we want to control the variables to see, okay, is it good or bad? It is vital in understanding the correct management to balance the rations to meet the requirements of the animal. We want to prevent digestive disorders. We want to see, okay, if it is a feed with a low fiber or very high ash content, okay, what can I do to correct for that part? And we want to prevent poor performance. We also want to prevent inefficiencies because the amount of land is limited, and to produce as much milk as possible from that land or from that forage, you need to have efficient nutrition. And also, that was for looking to the front, also looking back, okay, what went well? How did I treat my fields? And where can I do better? How did my preservation went? Where can I do better? Next slide. So the visual assessment is not good enough, and we need to measure. The old, very well-known person already said it a couple of ages ago. If you can't measure, you can't improve. So it's really important we measure quality of feed. Next slide. So I made a small, simple calculation what quality of feed does to milk production. I will take you through this slide. So the left-hand side, we see the NDF content of a forage. The look, as a rule of thumb, 1% of the body weight of the cow is your potential NDF intake. I put the maintenance of 38 points NEL, net energy lactation per day, based on a cow of 550 kilo. So if you click one time, Bhavna, the potential dry matter intake of the feed with 650 NDF is 9.5 kilo dry matter. The feed with 460 NDF, potentially the cow can eat about 12 kilo dry matter of this feed. Press one time, please. So the feed with the high NDF very likely has got a low NEL, a low energy value per kilo dry matter. And that's where the problem starts seeing. Next slide. So if this cow with a forage of 650 NDF eats 9.5 kilo dry matter times 4.8 NEL per kilo dry matter, she eats 46 points of NEL. The other cow at the lowest line, she will eat about 79 points of NEL. And then I subtract the maintenance, 38 points of NEL. And then there is left from milk production, 7.9 NEL in the one cow and 40.7 in the last cow. This means, one time click please, that potentially milk from roughage is 2.3 kilo milk from the roughage in the first line and 11.8 from the roughage in the last line. So this is what feed quality does to milk production, and it is really important, and that's why we are really always hunting for the better quality silage. Low ash, good digestibility, and that is extremely important, as you can see in this slide. Next slide, please. Next slide. So measuring the nutrient content in silages. We measure, of course, we measure dry matter. Can you go one back, please? One back, please. Other side. One up. Yeah. So we measure the fiber, we measure the NDF, the ADF, protein, ash, sugar, starch, and of course we measure dry matter. And based on these measurements, we do calculations on the other nutrients. Next slide. So we can take things to the laboratory or and do a wet chemical analysis, and that is a costly and it is a very timely, very time-consuming thing, but we need it for a good basis. About 35 years ago, Trouw started developing NAR calibration lines for different tools where we can do a very fast and quick assessment of raw materials. And so we first started with FOS machines. The last year we also were able to make lines for Bruker machines. These are laboratory machines. They're quite expensive. Not for the field, but for the office and for laboratories. But we can do very fast, very accurate assessment. And recent years, as Suya has already said, we are well able to make lines for a mobile application, which I can use at farm level. Next slide, please. So the NEAR network from Trouw, we have globally about 500 of these desktop NARs working in the globe. And last year we performed about 3 million, a bit more than 3 million analyses of feeds. And based on this, also we were able to make these calibration lines for the mobile application, the Nutrient On-Site Advisor. Next slide. And then always the question is, how accurate is NAR? Right? Because people do believe or people don't believe. But we are accredited for the desktop NAR that it is one time click, please. And that is in 2014 we got the confirmation that this is for the auditors just as good as the wet chemical analysis. And so here we set a really good standard for using NAR systems in animal feed analysis. Next slide. Next slide. So when you look at the lab analysis, the sampling is today. Then I send my sample to the lab, and it can normally takes 2 or 3 days before it enters the lab. Then it enters the lab. I do need to do the analysis and reporting. And then I am able to adjust my diet 4 to 5 days after sampling, which is quite some time if I have an issue. So the disadvantage is the time between sending and receiving analyzed. That's one. And that number 2 is the possible heating of the sample. And you very likely have sent sometimes a sample to a laboratory or have it in a bag a bit long, and you see the product can heat and can develop molds. So then also the question is, how good does the sample reflect what you have at farm level? Also, an analyze which you send to a lab is a one-off. So of your pile or of your bale, you send one sample to a lab, and you do not do that every week or very frequently. And so that's a disadvantage of a lab part, and therefore we are working last years more and more with the mobile NAR system. Next slide, please. So our solution, we say we bring the lab to the sample. It's the other way of thinking. We take the lab towards the farm or towards the silage baler. It's a portable online system. You have a handheld scanner and a mobile application linked to the Nutriop web portal. Next slide, please. So how does it work? I take a sample at farm level. I try to take a representative sample of the bale or of the silage pit. I perform the scan with tool. The sample is uploaded to our nutritional database. And by having it in an online system, I'm also able to continuously update this database. So I'm always able to work with the latest adaptation we made. I can generate a report. The report I can use for two things. One is for raw material quality control. For instance, when I'm a feed miller and I ordered soybean meal with 48% protein and I get delivered 42 or 41, then I'm able to refuse that shipment or renegotiate price maybe. And the other part is when I have the analysis done, it immediately enters our formulation systems. So I don't need to do hand typing, and it's a lot of preventing of error clearing. And so it makes life more easy and fast. Next slide, please. So this is the current way of working in some Western European countries where we are at the moment. So it's in Holland, in Germany we're quite far advanced, in the UK quite far advanced with using this technique. And also implementing it in the daily diets. The available raw materials for the NOAA, 20 April 2023. We checked, we have developed calibration lines, and I developed it in 3 parts for energy feed. So the real raw materials from energy side, so barley, wheat, wheat pulp, protein feed, like fish meal, like soybean meal, like rapeseed meal. Here is the full profile: energy, amino acids, fatty acids, the whole part. Complete feed, like broiler feed, cattle feed, fish feed. We are here able to do the approximates, and because the energy calculation per raw material is different, so do not give a energy value here. And for silages, this is the number of silages we have at the right hand side. So corn cob mix, grass, different types of grass silage, grass hay, and maize silage and maize fresh. And also we have fresh grass. And we have TMR, the total mixed ration. Also there can perform a scan. Also there I get, depending on the product, the approximates, or I also can get the energy and protein values of these products. Next slide, please. So looking at the screen, if I get the analysis back on my mobile phone, and then I get for instance here, the left-hand side is for the corn silage. I see the approximates. We see the dry matter, ash, protein, fat, fiber, starch. For silage, grass silage is in the middle. So there we see no starch, but of course we see the sugar. And when we put a raw material, like here it is a rapeseed meal at the right-hand side, I also can put we call it data standards. We say, okay, my product can be between 65 and 75 ash, for instance. Then in the green part, it will tell you where I am with my silage, with my product, with my quality. So here I immediately can see, do I have a deviation from what I expect, yes or no? If it's really an outlier, really outside my total, what I would like to have, then I would get a red dot. So showing this is really off. Next slide, please. In the web portal, what you can access via internet, we can also, for the quality systems, we can access this document, is the total analysis, and I can save it in my bookkeeping if I need this. Next slide. So what's the implication of the silage quality? We were talking about silage quality. So if we have a higher dry matter in my silage, that's the number one nutrient we measure, cows, and I do not correct, cows will eat less kilo dry matter will eat less kilo of the total TMR. Right? So that will be less compound feed what they're eating, and they therefore produce less milk. If my dry matter of my silage is lower and I still give the same TMR, the cows will eat more kilo of this TMR, therefore they will eat more compound feed, and there can be more risk on acidosis and feeding this product. So therefore I need to know the dry matter. Higher protein in silage, this means I would, if I could correct, need less protein for the same milk production, and therefore I could save cost, because typically the protein products are the most expensive product in my diet. One time click, please. If I have a lower protein in my silage and I do not adapt, you can imagine I get less milk. If I have a lower energy in silage, I need more compound feed for the same milk, or I get less milk. If I have a higher energy in my silage, I need less compound feed for the same milk, or I get more milk. And so we talk here, it's all about efficiency, how I work with my feed or my feed quality. The next slide. So what are then what's then the effect of that? We also look at carbon footprinting. So at the left-hand side, we see the slide, and on the horizontal axis, we see the amount of milk per cow per year, 2, 4, 6, 8, 10, 12,000 liter milk per year. And we see the carbon footprint, CO2 equivalent per kilo milk. And this goes down very fast in the area between 2 and 6,000 kilo milk per year, because we really dilute and we CO2 per kilo milk produced. So increasing milk production leads to a lower carbon footprint, which is relevant at this moment to prevent global, to at least help fighting global warming. So we are able to calculate the carbon footprint per kilo milk. Therefore, we need a couple of things. We need a local raw material basis, mainly silages and co-products. This means the material database should contain the amount of fertilizer used, how the land is used, all the other things. And for instance, GFLI makes such a database. Looking at developing this for India also at the moment, because this is the basis for a good carbon footprinting tool. Then you need to, for the raw materials, like wheat and barley, to know the origin of materials, the inclusion rate in the compound feed. We need to know the energy used in feed mill. We need to know farm details, the number of cows, the diets, the milk produced, the manure system, and a couple of other things. The next slide, please. So we developed tooling for that. We call it feed print, my feed print and my milk print. And feed print is for assessing the parameter for the compound feed. And my milk print is then using this compound feed in a ration, and also in the end and do a farm assessment. If you would click one time above now. And we see here the parameters I need for doing a farm. I took a farm in India here. And so I have the number of milk, the kilo of milk produced, 14,500 kilo milk, and the fat and protein content. I have here the energy usage. Need my dairy cows, the number of cows and the number of dry cows below, and the number of heifers. Within these dairy cows, I can also look at the diet and all the other parts which are behind. And click one time, please. Then I get, in the end, my total carbon footprint per kilo milk. Being at this farm, 2.7 kilo carbon footprint, CO2 per kilo milk. You see it in this part impact. And this is based on the consumptions, this meaning the energy, the rations, the feed I provided, the enteric methane, and the methane produced from manure, and nitrogen oxide. And in this way, we can see, okay, what is then the impact of better quality feed, or more milk, or more or less animals, or different manure system. For instance, also your manure, you can also look at biogas, and in your manure, methane will also be lower. And so in this way, I think we made a circle from the feed quality or forage preservation, the importance of quality, what we can do with it to increase efficiency at farm level, and also made a small step to the carbon footprinting of milk, which I think will be a topic of increasing interest in the years to come. And with that, I would give it back to you, Bhavna. Thanks.
Thank you, Allard. It was really a great presentation. So now we have our Q&A round. We have received a lot of questions. So I'll be starting with the first question. So the first question is, how much silage should be fed to milking cattle? Suyash, answer this question.
Thanks, Bhavna. It's really interesting question. I would like to give answer in short. That question is not how much silage needs to be given. Question needs to be how much dry matter I need to give. So basically, it depends upon the stage of lactation of the dairy animal, total body weight, which is given to, which animal carries, and dry matter calculation. And once you are able to understand that what is the total dry matter requirement of animal, according to that, roughly around 2/3 comes from forage, and then major portion should be covered with silage. And those who are not aware about the dry matter calculation, for them, but a straight calculation I can give: any animal which is producing roughly around 20-25 liters of milk, you can consider that equal amount of silage needs to be given.
We have our next. Thank you, Suyash. We have our next question. To get maximum nutrition from silage, how many days gap should be between ensiling and feeding?
Allard, shall I take this question?
That's good. Yeah.
Fair enough. Thank you. It's about when I was explaining that particular chemical process of the silage, where I have clearly mentioned about a storage phase. So it should not be before storage phase. And after storage phase, minimum plus 15 days we suggest, so that a lot of enzymatic reaction happens, enzymatic process happens, which increases palatability of silage. So effectively not before 21 days. And for good quality silage, it's important not before 40 days.
Thank you, Suyash. So there's another question. Can we add toxin binders before ensiling?
Toxin binder incorporation in silage is, as I mentioned, that these are the old age thought process, because as you know that toxin binders are very fine material which are highly hygroscopic. So in my opinion, it should not be. We need to acidify silage. So for anything which improves its acid profile, which can bring down pH, should be added. So we are of opinion that no molasses, no urea, no copper sulfate. Either you should go for high quality organic acids or very good quality heat stable inoculants.
Thank you, Suyash. So we have a few questions on silage bales. So I'm just clubbing those. So what is the best way to stack silage bales? And we have another question where someone asked, can the silage bales be stacked under direct sun?
I would like to give this question to Allard.
Can you please repeat the question, Bhavna, because I didn't get it totally.
Sure. So what is the best way to stack silage bales?
Yeah, that is like Suya showed one. Dr. Suya showed one slide earlier on, slide 22, where they're very well stocked on a solid floor, and then very nice packed on each other. So I think that's the best way to pack them. Slide 22, maybe you can put that one on the button.
And also, we have another question related to silage bales. Can the silage bales be stacked under direct sun?
Yes, it's not ideal, however. You can imagine that the sun will heat up the feed a lot. But that's where, yeah, there is an ideal situation where you say maybe it can be covered or whatever. But you also have to live with the practicalities of being able to have them stored in a darker place. That's the ideal world. But we also know that the ideal world doesn't exist. So we have to live with what we can do. So therefore, it's very important to do a very good preservation of the product during ensiling, during baling. I think that's the most important part.
Thank you, Allard. We have our next question. What is the variation or range of DC/AD value of corn silage?
Allard, it's decade actually.
Yeah.
Yeah, you take that question, so yes, I'll take.
Yeah, you can take, no worries.
Well, decad is, let's say, in the end of a diet. So when you make a total diet, decad is very relevant. And so what we see, for instance, in the Netherlands, we have grass silage with a lot of potassium. So therefore, the decad values of the grass silage are typically higher, and corn silage contains less minerals, so decad value is lower. And so if you want to influence, you can, of course, you can play with the amount of grass and corn silage. You can also play with certain minerals. The exact variation in corn silage, I didn't calculate it because I always look at the total diet, because that is relevant. Do I feed it to my dairy cows, or do I feed it to my dry cows close to calving? That's where you want to make the difference in the DCAT, the dietary cation anion balance. But let's say if you have a lower, potentially a lower sulfur, so lower sodium, lower potassium content in your corn silage. Therefore, typically your DCAT will be close to zero.
Thanks, Allard. So we have our next question. Apart from pH reduction, what are the specific chemical or nutritional transformation that occur during silage preparation?
Can you repeat
Suyash, can you
this
take
question? Yeah, sure.
Yeah.
Can you repeat this question, please?
Apart from pH reduction, what are the specific chemical or nutritional transformation that occurs during silage manufacturing?
Okay, that's great question. One slide actually I have shown during my presentation where entire chemical process I have explained, but for again I would like to tell that particular point, that whenever we are ensiling, first day one starts with respiration of the plant cells, where potentially basically sugar gets interacted with oxygen, which is still available. So there is CO2 formation, setup of anaerobic condition, water and heat. This is first chemical change which happens in that. Second change happens that it should go towards acetic acid formation. And if clostridial means soil contamination is higher in silage, then automatically it goes for clostridial contamination, and butyric acid may produce at that point. If it is not, acetic acid set up template for lactic acid production, and there are also mannitol and other substances are produced there. And simultaneously, as this process starts, pH starts going down. So by 3 to 6 days, pH goes around 4, and after 7 days, it must be less than 4. That's how the good quality preservation happens. and lactic acid, acetic acid, and other organic acids needs to be there. So these are the major chemical changes which happens during process of ensiling.
Yeah, if I may add one thing to that, if you have a corn silage and you have it stored over time, so 3, 6, 9, 12 months over time, then also the amount of bypass starch will reduce in that silage. The amount of starch will stay about the same, but by the fermentation process, the starch, the bypass starch will transfer more to rumen available starch. So that's one process what we also need to take into account during the year after ensiling your corn silage.
Thanks a lot for complimenting it. Thank you.
You both. So we have so many questions here. So we'll take up another two questions, and for all who have asked the questions, we'll come back to you personally. We'll be clarifying all your queries. So the last two questions, how does grass silage preservation differ from corn silage preservation? Suyash or Alad, anyone can take up.
Allard, you can take up.
Yeah, I think corn silage preservation, you have one chance. That's for me always the biggest takeaway. One time per year you harvest your corn silage, you have one chance, so you better make sure you do it very well. So in grass you have more chances, so if something might go wrong, you maybe have a next cut where you are able to repair some things. The important thing is because of the corn silage, when you harvest it on the right way, and so it's also slow to show slide on the dry matter of corn silage when to harvest. You harvest on the right way, you can add some silage preservatives. Almost every time goes very well. In grass silage, your variation will be all over the place. You can have a pretty wet grass silage. You can have a pretty dry grass silage. You can have a very short field period or a very long field period. So in grass silage is more difficult, and you need to take more things into account. Ideally, you have that field period of 1, maximum 2 days before you put it in a silo or in a bale. And but your sugar content can vary a lot. So based on that, you also need to make the right choice for your preservative. So in that part, the grass silage making is a bit more complex than the corn silage making. I hope that answers the question.
Can I compliment Allard here?
Sure. Yeah.
So just to complement what Allard is saying, if you would like to understand in deep, basically, what is the basic difference between corn and other grass silages, in my slide I have shown basically the nutritional profile, where specifically I was talking about the nutritional content of corn silage vis-a-vis to wheat, oat, sugar grains, and mixed grass silage. So if you look at the starch content, the moisture, and NDF content, it varies a lot in grass silage. So it depends upon the fermentation process. Corn is being considered as best suited because it has interwoven matrix of starch. And starch is basically, it encourages, it's a food to bacteria which is naturally occurring in the corn silage. So preservation quality of corn is comparatively higher, and mineral profile is rich basically in grass silages, which particularly Allard has highlighted about the potassium content. So basically buffering becomes difficult for grass silages. That's why silage preservatives plays a great role in grass silages, and similarly what it plays in corn silage. So if you would like to understand deep, then kindly just shoot a mail to me. We will be able to interact further on it. Thank you.
Thank you, Suyash. One last question. How to control nutrient drainage or effluent flow? How much loss can we expect per ton silage in bunker method?
Interesting question, Allard. I want if you can take it up.
The nutrient loss, it's a difficult one. You have already lost at the field.
Yeah.
So The nutrient loss can be, let's say, between 5 and 10%, of depending on how you call it, secure you are, how accurate you are with making your silage. And then what you meant on effluent loss, of course, a wet product will lose then water when you put it in a bunker on the field, or in a silage bunker. So with the effluent, you also will lose your lose some sugars and some soluble protein. And so therefore, it's important you can analyze fresh feed, and therefore it's important to analyze your silage, because that's the product at the end which you will be feeding. So then the analyze as possible, short as possible before feeding, and because you also then can take into account the changes which happened during ensiling. But the amount of nutrients you are losing is really depending on the dry matter of the silage and how good the silage process was. But typically between cutting in the field and what is coming in front of the cow, your loss will be between 5 and 10%. Maybe Suyash, you can have addition to that.
Yeah, absolutely. Thanks a lot for this. In tropical climate, that's why I keep on telling every silage processor and farmers that normal dry down time is 1.5%. Better your preservation practices or management practices are, lesser the loss of nutrient in silage. In high quality silage is what Allard is talking about, somewhere we can expect minimum 5 to 10%. In bad quality silages, I have seen as high as even 25%. If you are preserving very high moisture corn, process loss will be more. Nutrient drainage will be in terms of seepage, whatever during compaction happens. So it's very important to look into all the things. In the end, I would like to suggest everyone that if you would like to make good quality silage, you need to do all the things correct. Anything which is missed out, you will be having losses in terms of silage. Thank you.
Thank you, Suyash. So we'll close the Q&A round here. So all the questions we have received which are not answered will come back to you personally, and we'll answer all your queries. Before we close, I would like to thank all our speakers for the valuable presentations, and also all the attendees who have joined us today. A very thank you so much to one and all. So we have also displayed our contact details on the screen. So you can reach out to us anytime for any queries. Thank you. Thank you,
Thanks a
everyone.
lot. Thanks,
Thank you.
everyone.
Thanks a
Thank
lot.
you.
Bye-bye.